If there's one concept that unlocks LangGraph, it's state. State is the data that flows through your entire graph. Every node receives the state, can read it, update it, and returns the updated version. In LangGraph, state is defined as a TypedDict, a typed Python dictionary. Here's a simple example. You define a state with messages, a list of conversation messages. Every node gets the state as input and returns updates to it. The graph automatically merges these updates using reducers. What's a reducer? For the messages field, the default reducer is append. New messages are added to the list. You can define custom reducers for any field. Now here's where it gets powerful, checkpointing. LangGraph can save your state after every node execution. If something fails, you can resume from the last saved state. If the user wants to go back and change something, you can rewind. For your job search agent, the demo project will build. The state will hold the user's query, the job listings found, company research results, and the final cover letters. Every node reads and updates this single state object. One more thing, thread IDs. When you add a checkpointer, each conversation gets a thread ID. Different thread ID means different memory. Same thread ID means the agent remembers you. This is how you build a chatbot that remembers users across sessions. Next video, MCP. The protocol that lets your agent connect to anything.